Hello. So let's talk about how we measure inequality, specifically the Lorenz curve and the Gini coefficient, the most often used measures. The Lorenz curve shows us what percent of people earn what percent of income. So along the horizontal axis, you see the cumulative percent of population. We line up 100% of the population from the poorest 20%, the next 20%, the next highest income 20%, all the way up here. This is the 20% of Americans with the highest incomes. So we sort of line up by incomes. And then on the vertical axis, we have the total percent of income, and that is additive also. So 20%, then the next 20%, so that's 40%, and on and on and on. So let's graph the data. The actual data here are in red, so the bottom 20% earn something like 4 or 5% of total income. That's that data point. And we match up the data to the people, and we see that basically the bottom 60% or so of Americans earn less than their, quote, fair share, earn less than 60% or whatever of their income. And that doesn't really begin to catch up until the top 20%. They earn more than 20%. So if this country were in perfect equality of incomes, we would track along this blue line, right? 20% have 20% of the income, the next 20% have their 20%, so that would be 40% and 40%, and on and on and on. So no country has that line of perfect equality, but some countries are more equal than others. So the Lorenz curve is really useful for comparing one country to its own past or one country to other countries, but it's a little bit bulky. So we've got a shorthand way of expressing inequality using that Lorenz curve, and it's basically this. We can take the Lorenz curve, right? And it's clear that the more bowed out the Lorenz curve, or the further away it is from the line of equality, you're going to have more inequality, right? So if we shade in the area between the line of perfect equality and the actual Lorenz curve, we get area A, and the larger that area is, the more inequality we think we have. So the Gini coefficient is the area A over the area of the whole triangle under that line of perfect equality, or A plus B. So higher inequality will have a more bowed out Lorenz curve and a higher Gini coefficient. And so if a country's Gini coefficient is rising, the Lorenz curve is getting further and further away from the line of perfect equality, you're going to get something like this. So this is a larger A, and you're going to get a higher Gini coefficient. And conversely, our lower Gini coefficient correlates with a lower inequality and a Lorenz curve that is closer to the line of perfect equality. So you might be wondering what some actual data are. Here's the US, 1974, and in 2014. So our Lorenz curve is getting further away from the line of perfect equality. And can you guess what our Gini coefficient is doing? That's right, it is rising. And here's some more data. So this looks at, there's a lot of information on this slide, and it's a little bit fuzzy, sorry about that. The US redistribution does lower the Gini coefficient. So in the light blue, the top bars for each country is the Gini coefficient before redistribution, so that is taxes, transfers, and other sort of Robin Hood things that sometimes the government does, social safety nets, etc. And so we do have a lower Gini coefficient after redistribution, meaning that our redistribution is doing what it's intended to do, and that is lower the very high inequality that the US has. The UK has an even higher Gini coefficient in the year 2010, but they do even more redistribution. And you can see that, you can look at all the data on your own, but you can see all sorts of differences in the amount of pre- and post-redistribution Gini coefficients. Pretty interesting to see how countries handle their inequality. Ireland is notable for its massive redistribution. All right, quick check. If a country has an income distribution that is perfectly equal, the Gini coefficient would be 0. Good job, I hope.